We've had a long-standing with Yatex and providing really high-quality borescopes to the market. And this is one of our newest versions of that, called the Realta. And this one specifically is actually 3D measurement, which is a big ask in the aviation market, welding, even turbine blade inspections, right?
All right, yeah, let's take a look at the form factor of this video borescope. So just on first glance, I notice it's a substantial size, pretty robust, nice screen.
So we wanted that nice large LED screen, right? But we also wanted some portability in this form factor. I think we hit that nice balance of form factor, weight to, portability ratio, right? And as I was talking about before, this is kind of a modular system. As you pull up, the probe will come right out, right? So one great thing is replacing probes. So we have our repair program, of course, but when customers are on a crunch, needing to get those inspections done, you're able to swap out probes on the fly, power it right back up, and you're ready to go. It's replaceable, repairable, yet also very versatile.
And you were mentioning there's 3D versions as well as non-3D versions, and they all work on the same platform?
Same handset. A lot of it's software based that the handset itself is doing. It'll recognize the 3D probes inserted. It'll boot right up, work every single time.
How about we power this on and maybe you can further describe what's going on with the software and maybe some of the other features.
So it's very simple. Power button right here. Hold that for a few seconds. You're gonna see a nice splash screen from us. And as you can see here, really crystal clear image, 2 megapixel. This one specifically is a side view probe. As I was mentioning before, where we have front view or side view available on 6 and 4 millimeter for 3D measurement capabilities. So a couple of the features you see outright, you'll see 2 joysticks here. This larger one is for your articulation. On 4 and 6 millimeter, we have 4-way, so all-way 360-degree articulation available standard.
And I noticed, I don't know if our mics picked it up, but there was a slight sound that sounded like a motor. So these are motor-driven articulation?
Yes, that is correct. So there's kind of 2 thought processes. One is a manual articulation, where you're gonna get a nice tactile feedback and have a little bit more control over the articulation. But with servo motor, you're gonna get that really smooth and reactive articulation, right? You have a lot of control as well as the ability to lock it in place. So let's say you find what you're looking for, you're able to lock it in place. So you don't move it away from the object, you capture your image or your measurement, you move on.
How did you do that actually?
You just hold it down for a few seconds.
Oh, okay.
So about 3 to 4 seconds.
Oh, wow.
It'll lock in place. Once you're ready to move on, just tap the joystick, it'll go right back to home.
I guess I'm also noticing, looks like there's 2 screens, almost like a picture-in-picture with, looks like RV and LV. Can you describe what's going on there?
So with that, that's actually the software itself. So inside here specifically, there's actually 2 sensors, right? If we lower the light here.
Oh, I noticed, so it's a touch screen as well?
Touch screen as well. So you can see there's 2 sensors in there. That's used for stereoscopic measurement. So we have a couple sample pieces here. The stereoscopic measurement does not need to be calibrated, but for quality control and assurance, we provide these pieces here that allow you to verify the accuracy of your probe, right? So this piece right here, this is gonna be for depth measurement, which is a really important feature on a lot of 3D measurement scopes, right? So what we're gonna do to take our image capture, tap the screen, see this caliper tool right here, we're gonna click that. After a few seconds, it's gonna capture our image and you're gonna see that 2 screens again, right? So here on the left is your point plot data, right? Where you're gonna actually be doing your measurements. But a really cool feature of this on the right side is you're gonna get a 3D rendering of what you captured. If you find, let's say, a crack and you're trying to see the divot in the crack, how deep it goes, this is gonna give you a visual representation of that.
About how accurate is this measurement?
So it was calibrated to within 0.05 millimeters, plus or minus. So it's relatively accurate. And if we were going to do our measurements, you have quite a few options here, as you can see. But kind of the most important are these 2 right here, point to point and then point to plane. So this one specifically is going to be for when you're measuring the length of a crack inside of a pipe or a turbine blade, let's say, right? But what we're going to do right now is the point to plane. We're going to choose 3 points on this top plane here. You see this ring? That's our top plane. And you can see we've added a magnifying glass to help give you extra accuracy, as well as the second joystick is going to be used to control your plot point.
Oh, I see. So the second joystick, it seems to be moving the cursor, like the point cursor.
Exactly, right? And when we're ready to put our first point down, we're going to click OK, move on, make sure we're in a nice spot. Second one, third one, hit OK. And then our fourth point is going to be our measurement. So once we move down here, you're going to see a slight preview as well as you move along. And you can actually follow along on the point cloud as well.
So you're measuring, since this is like a, looks like a little divot in the test piece here, you've created a nice planar measurement across the top of the divot.
Exactly.
And then this is a perpendicular line from that plane to the bottom of the divot.
Exactly the point.
Gotcha.
Right, and you see every piece is not perfect, even something that's machined out, so you're going to see some ridges and valleys. And as you move along and get that preview, you're getting as much information as you need back.
Zach, it was a pleasure having you back up here in New Jersey from Texas.
Of course.
Thanks for taking us through this great system.
For more information on the Yatex Rialta 3D measurement borescope, visit our website at intertest.com. Browse our selection of video borescope probes, handsets, and technical information for your remote visual inspection needs.
Go. And our 3D measurement system provides 6 different kind of measurement mode, and we can press this button, add measurement, to add a different kind of measurement mode. For example, we can calculate the point-to-point distance. And first, we need to add 1 point, and we can adjust the point location by using the arrow button and the magnifier. For example, we can use the arrow button to adjust the location of the point and press OK to confirm. Next, we select the second point and press OK. So the distance between the 2 points is calculated and shown here. And we can also compute the point-to-plane distance. And in this measurement mode, you need first to select 3 points to determine the plane. And select the first one, the second one, and the third one. And the 3 points determine a plane, and we need to select a fourth one, a fourth point, for example, here. And the distance, the perpendicular distance between the fourth point and the plane determined by the first 3 points are calculated. Okay? And we can also export the 3D mesh data to file by pressing this button. Okay? And we can also undo the 3D measurement by pressing this button. And we can delete all the measurement by pressing this button. Yeah.
手机上啊。